Okay, so we're going to now do one more example here. We're going to do, let's go ahead and do cubic approximation of the inverse tangent of x centered at, I believe I want to do 0. Let me just double check to make sure that's what I want to do. Yeah, that's what I want to do. So, we know we're going to need f at x, f prime at x, f double prime at x, and f triple prime at x. Well, f at x is just the inverse tangent of x. Now we need to remember the derivative of the inverse tangent of x. Well, that is 1 over 1 plus x squared. So I'm going to rewrite that as 1 plus x squared to the negative 1. So the second derivative would be pretty straightforward. Using the chain rule, you get negative 1 times 1 plus x squared to the negative 2, but using the chain rule, we'd multiply this by 2x. So if we wanted to write this out, I'll do it here. This would be negative 2x over 1 plus x squared quantity squared. Now we have to do the third derivative, which this one's not fun. You can do it either product rule or quotient rule. I'm going to go ahead and just do quotient rule here. So I'm going to just write this in red here. So we have negative 2 times my bottom minus the top, which is negative 2x, times the derivative of the bottom, which is kind of a mess, all over the bottom squared. Okay. So f triple prime at x would be negative 2 times, bottom squared squared. So this would actually be squared as well. Yeah, forgot about that. Negative 2 times 1 plus x squared squared plus 2x, and then this would be times 2, 1 plus x squared to the first power times 2x. And this is all over 1 plus x squared to the fourth power. Alright, so we got the derivatives here. And this looks like a pretty ugly derivative, which is why I only went to the third power, because you can just imagine going to the fourth power. So what do we get here? Well, we need to evaluate these at my center. The inverse tangent of 0 is 0. And then I need to evaluate the first derivative, which is 1 over 1 plus x squared so it'd be 1 over 1 plus 0 squared, which is 1. F double prime at 0. Well, let's scroll back up here to see f double prime. This would be equal to negative 2 times 0 over 1 plus 0 squared squared, which would just be 0. So f triple prime at 0 would then be equal to negative 2, 1 plus 0 squared squared, plus 2 times 0 times, and I'm just going to go gunk here, because let's think about this. I don't have to write any of that down, because I got 2 times 0 times all of this garbage here, which we know is going to be 0, because I'm multiplying by 0. So kind of a little short over 1 plus 0 squared to the 4th power. So after all of that, we get negative 2. Let's double check here. 1 squared times negative 2 is negative 2 divided by 1 to the 4th. Alright, so my cubic approximation then would be 0 divided by 0 factorial, x minus 0 to the 0 power, plus, well, what was it for the first derivative? It was 1, right? Yeah. 1 over 1 factorial times x minus 0 to the 1st power, plus 0 over 2 factorial x minus 0 squared, plus negative 2 over 3 factorial x to the 3rd power. Well, it's technically, let me make sure, it's technically x minus 0 to the 3rd power. Alright, but then look at this, I've got a 0 here. Well, this would be 0 divided by 1. This term is just 0 now, just like this term. So in reality, my L3 approximation doesn't involve all of the terms. It's just going to be 1 times x, so it's x, and then it's minus 2 over 3 factorial x cubed. Now we could simplify this a second here. If I think about this, 3 factorial is 3 times 2 times 1. So I could simplify and write L3 as simply x minus 1 over 3 times x cubed. And maybe we'd have to verify it, but maybe we would be lucky in that if we, well, you can probably guess the 4th degree term is going to be 0. But maybe we'll be lucky and the 5th degree term would just be 1/5. But we'd actually have to go through and do all those derivatives and simplifications to determine that, which we're not going to do. Okay, so this kind of gets us pretty close to being done with polynomial approximation. There is one other thing that we're going to talk about in the videos, but we're not going to do it so this is the end of the videos for today.